was torn because I wanted to help him and be like, look, dude, just go use my YouTube page because I'm teaching this right now and there's free videos. But then I make $40 if he pays to tutor me. So that's a conflict of interest. So anyways, y'all get free tutoring. $40 an hour. You get free tutoring because I'm making YouTube videos. And they're on YouTube. They're on our Google Classroom. I say this to say use it. Okay? Because a lot of college professors, and by a lot I mean all but majority, like maybe 5 people, don't offer those services. They expect you to go to pay someone or to the free tutoring services at the school, not in the convenience of your own home. Okay, so look at number 5.5. We're taking everything we've learned, we're putting it together to solve. So the goal here is we're taking exponential equations and solving. We're taking logarithmic equations and solving. It is very confusing if you're not looking at the big picture. And the big picture is the conversion from one form that's not helpful to a form that is helpful. That's the goal. Recognizing what form's it in, what form can I convert it to, which one is more helpful that I can actually solve. Okay? So it's kind of like a puzzle. Let's dive right in. Let's start simple. There is a base exponent property. The property is written right here. To understand it, they're saying for any number greater than 0, meaning your base is greater than 0, as long as it's not 1, because if it was 1, then nothing interesting happens. If you have base a to some x power, then you have base a to some y power. Because the bases match, you can go straight to just looking at the exponents, and they should match as well. They should be equal in value, and then you can solve that. That's what it's saying there. So let's make a note. When the bases match, the exponents must be equal. When the bases match, the exponents must be equal. We're going to start very simple on a foundational level, and that would be with this example right here. It's not even labeled as an example because it's too simple. We have 2 to the 5x and 2 to the 6th. It says 2 to the 5x equals 2 to the 6th. The x is in the exponent's position. We don't want to convert to the log here because we should notice that the bases of both of these are 2, which means they have to be raised to the same power. So because these bases match, underline it right there. I'm going to draw arrows right here. And I'm going to make a note. They match. This is why I can say, oh, okay, so 5x has to equal 6. Divide by the 5. This whole board is shaking. Not the board, not the board, yeah. That'd be my look. That's what I do. There you go. It's not a big deal unless you're standing right up here at it and it starts shaking.
I saw the woman who got hit with my spot.
I guess I've got a purpose. I haven't fulfilled my purpose. Yeah. That's good to know.
Just saying you're lucky. You're good.
I am lucky because there's 8 sharp corners and that thing weighs 8 pounds. Probably more, you're right. It's old.
They get heavier.
We got that. Look at the next equation. When you first look at it, your first instinct is probably, okay, we can't do this differently because the bases are, like, we don't have, over here we have 32. We don't have 2 to some power.
Yeah, but it can be simplified to 2 to some power.
We can manipulate this. This can be solved two
Manipulation
ways.
is fun.
The first way is to recognize it's in exponential form. The inverse of that is logarithmic form. So I could change this to log form, or I could say to myself, wait a minute, now I can take 2 and I can raise it to a power to get 32. Then you have to kind of play with it. So you know 2 squared is 4, 2 cubed is 8, right? 2 to the 4th is 16, 2 to the 5th, 32. So you ask yourself, can I rewrite this number as that base to some power? And if you can, do it, because then you can go straight to the exponents. So let's make a note. Bring this down. Then I'm going to rewrite this as 2 to the 5th. And then I'm going to underline those. And in the same format that I did over here, I'm going to say, hey, they match. Since they match, I can disregard the base and pull the exponents straight down and say, okay, then they have to match. So x has to be 4. The other nice aspect about this section, take that extra 5 seconds to check it. Go back to the original, and in the original, you would type in your calculator one side to confirm if you get the right side. So you would go to your calculator and type 2 caret 3 times 4 minus 7, enter, and you would see if you get 32. And I do. So now I know I got it right. It does not take long to check that, and I encourage you to do that because 1, it builds procedural fluency, and then 2, it also gives you that boost of confidence as you go to the next problem. Okay, so go to this slide right here. This slide is saying now, here's a different type of equation. This is when you cannot necessarily rewrite that number as that same base to a power. There's no way to get 20 out of taking 3 to a power. Like 3 squared is 9, 3 cubed is 27. I've already gone past it. You see what I mean? So this is a different technique, and they're showing you right here. And if you look at it, it's probably really confusing. The beginning part of it is saying, hey, just make sure you got positive numbers, like m's positive, n's positive, a's positive, as long as a is not 1, because in that case, it's boring. And then they're saying, remember that the logarithm of log base a of m, if it equals log base a of n, then you can say that the of part, the m, has to equal the n. It's a similar concept of what we just did where we said the exponents must be equal. This is the of part must be equal. If they're both log base a, same base. All right, so look at number 2. Notice what form it's in. Exponential or log? It's exponential. You'd see the word log, right? Or you'd see O. Remember that the base of the exponent equals the base of the log. The other two switch. And I like that the log and the exponential part to be on the left for me to use this little technique. So this is the base of the exponent. So it's going to be in log form, log base 3. And the other two do what? They switch. And there's no more exponential. Notice when I rewrite it in log form, now x is by itself, and it's out of the exponent's place. Which means now I can go to my calculator and get the actual answer. To go to your calculator, I'm going to write it right here. You're going to hit math. You're going to arrow up, and you're going to use the one that says log base. And it's going to allow you to type it in that exact format. You could use the change of base formula, which we did learn, but there's no need to because it is in your calculator where you can type in any base. Let's go to the nearest thousandth. So x is approximately what? Yeah, I got 8 for some reason. Is it 8 or 7? I got 2.726. 8. I said thousands. 10 thousandths. 10 thousandths. I don't know why, but log equations you round to usually 4 decimal places. All right, look at example 3. So when you're looking at it, you have 100 times e to this equals 2,500. I don't want to convert it yet because I don't have e to the power by itself. What's in the way? The 100 is attached in the front by multiplication. You could move it over here to a power on the t, on the 0.08 t. I would not do that because then that's going to create more work in the end. I would say to yourself, okay, that's attached by multiplication, so I'm going to come underneath here and divide, and whatever I do to one side, I got to do to the other. Now, 2 ways to proceed. This is where people start to get confused and they start to say, I don't know when to use which one. That is an exponential form, so you could convert to log form. When you do convert to log form, you're going to end up with log base e, which is
Natural log.
ln, natural log. You can circumvent, like you can cut out that step if you know that when there's an e, I want to switch by, or I want to convert by using ln. I want to solve by using ln. Because what is ln of e? 1. It's like what you asked me to go over at the beginning. Anytime you have ln of e, you get 1. So remember the rule in math, I can do whatever I want to one side as long as I do it to the other. So I'm going to change colors so you know that I'm like talking out loud here. I'm going to apply ln to both sides. I spelled both wrong. It's alright. I'm going to apply ln to both sides. As long as I don't spell it wrong in my research paper, I'm good. Alright. Grammarly should catch it, so that's okay. I blame Grammarly. They don't catch it. You can do whatever you want to one side as long as you do it to the other side. So when I say apply it to both sides, I'm also going to go to another color here so you can see. I'm literally coming in front and saying, all right, we're going to do an ln here, and all right, we're going to do one there. So I've got an ln on both sides.
Mm-hmm.
Now, why did I do that? You might think, well, Ms. Holcombe, you just made that worse. What's this? ln of e. That's just a 1, and this comes down. Okay? If you need to remember, ln of e is 1. Recall that. So now we have 0.08 t equals ln 25. As ugly as that looks, please don't think ln are variables. Ln is a function. It's like sine, cosine, tangent. You are not solving for ln. You're solving for t. So in this equation, now t has been pulled out of the exponent. Now the only thing in the way is the 0.08. It's attached by multiplication. I will move it by division. And thank goodness for calculators that I don't have to do this in my head.
So is that not just transforming it?
Yes.
So that was just no lie.
I didn't.
Well, when I first did it, I just.
So if you, yeah, let me
And I got
finish
that.
this and I'll show you. So you would end up with 40.2359. That's the cool thing about solving logs and its exponentials. Well, solving E equations. I will change colors and show you, like right here. Had you forgotten about the ln thing, you could have said to yourself, okay, the base is E, so that's log base E, and the other two switch, so that's this, right? And then you would say to yourself that right here, T is almost by itself, I'll divide by 0.08. That cancels, and then this ugly mess right here would just get divided by 0.08. And you would type that in the calculator. So it is the same answer. It's a different technique. Purple technique is applying ln to both sides, so the ln of E will cancel. The teal technique is taking the E exponential expression and switching it to log base E, and then typing it in the calculator. The good news is it does not matter which technique you use. So find one you like and stick with it. I'm going to come over here and I want you to write this. Ask yourself, ... sorry. Ask yourself, which is it? Which is it? Is it exponential? Because if it is, then go to what? Logarithmic. If it's logarithmic, go to what? Exponential. So you ask yourself, which one is it? And then you switch to the other one. And you see if it's helpful. And it should be if you did it right. All right, go to example 4. Solve 4 to the x plus 3 equals 3 to the negative x. Okay, what format is it in? Exponential. Let's go to log. Now, we have an exponent on both sides. There's a difference here, right? If you go back to the previous examples, there was only an exponent on one side and switch to log form. We have an exponent on both sides, so you can't necessarily switch to log form. You can apply logs. Just like we applied ln to both sides, we can apply log to both sides, and it will force the conversion, and it will bring everything out of the exponents and allow us to solve. So let's make a note. I'm going to draw an arrow here, and I'm going to write apply log to both sides. What does it mean by applying log to both sides? You're shoving it right in front of the expressions. So we've got log 4, and I'm going to put x plus 3 in parentheses because there's more than one thing there. And then log 3 negative x. Now, at first you probably think we made it worse, but we're going to now use what we learned in 5.4, and those exponents are going to come to the front as coefficients. So I'm going to change colors and draw arrows to show this is going to come here, and this is going to come right here. Now, remember, watch out for your, this is in parentheses. Then we have log times log 4 equals negative x log 3. You have a binomial x plus 3 with something that is being multiplied to it. It's log 4, and it looks weird because it's after the parentheses. If it bothers you, just move it to the front, but this is a distribution step. We need the log 4 to distribute to the parentheses. You need to know that this x plus 3, it stays in the front of the log. Log 4 stays intact, okay? You don't shove the x into the 4. You don't shove the 3 times 4. You don't do that, okay? So it's x plus 3 is going to get multiplied as coefficients of log 4. So I get x log 4 plus 3 log 4. And on the right, I have nothing done yet, so I bring it down.
So we use that property. We use that property we learned in top 4.
We use the power property up here with the teal.
Right.
This right here is just common distribution.
I got you.
You don't use the, are you thinking of like subtraction becomes a fraction? And,
Yeah.
No, that's when it's the of part,
I see.
not when it's a coefficient.
Right.
Yeah. You just saw the plus sign and you're thinking, yeah. That's when it's like log of parentheses. If it said x plus 3, then yes, you would. All right, what do you notice in this whole equation? What do you notice? You're solving for x.
Oh, that's.
Try again. Go back to what you were about to say. First thing. You did. X is on both sides. We have an X on both sides. Do you see that? We've got one on the left, one on the right. That's not good. We need them to be on the same side. If we're trying to solve for X, we need them consolidated. So let's make notes over here to the right, kind of out here next to it. We're going to say rearrange. So you end up with the x's equals some number or some log, like the other stuff. You know what I mean? We need the x's on one side. We need anything that has no x on the right side. So it's a cup game. Okay, y'all stay with me. Everybody stay awake. It's a cup game. This expression right here, 3 log 4, has no x. It's positive, so I'm going to subtract it to the right-hand side. This expression, negative x log 3, which is linked together, okay, so don't separate it. It's a cup game. It's negative. I'm going to add it to the other side because it has an x in it. So this is going to switch to over here. You see that? And I end up with, now this did nothing, so this comes down, x log 4. That moved left by addition, and 3 log 4 moved right by subtraction. All right, what do you notice? Now the x's are on the same side, and where are they?
In the front?
They're in the front as a coefficient, which means they are a 3 letters. GCF. There's a GCF in front of both terms. There's 2 terms here because there's only one plus sign. There's a GCF of x. We can take that x to the front as a single term. I'm going to factor it to the front. What would be left? Log 4 plus log 3. x's are now consolidated. I have a single x, and I'm so close to it being by itself. All I have to do is divide that. It's a cup game. Log 4 plus log 3 just shifts to the right as division up underneath -3 log 4. So this whole mess right here, I'm going to mark it out, divides to the right. If you need to see it over here, you can write it right underneath. Log 4 plus log 3, and those would cancel. Now you're not quite done. You do have to go to the calculator, because while this is the expression for the answer, it doesn't actually tell me the number. Like, what is x? What is x equal? Just tell me the answer. So you go to your calculator and you type it in. Which log button are you going to use? Yeah, the regular. Notice we never talked about a base. That's because it's understood base 10, which means you can use the regular log button on the calculator. So, type a fraction. We got -3 log 4, close the parentheses. Then we've got log 4 plus log 3. So the answer is -1.6737. Ish. Rounded, sorry. Don't turn the page yet. I meant to, right here, let's make a note. Right here, what we did was factor out x. That's what we did there. Then I want you to draw a square. Okay, I like to practice a little bit of everything, so I'm changing it, I'm tweaking it a little bit, and I'm going to say, what if this had been your problem? What if you had this?
You separate them again.
Huh?
You separate them again.
What do you mean? You could sine, cosine, tangent. They're attached. The only way to get rid of log is converting to exponential, or the log's already there.
They have the same base.
What?
They have the same base.
There it is. All right, where are we going? What's equal? Be specific.
5x minus 1 is equal to x plus 7.
There you go. Okay, so notice the three. They're both logs. They're both log. That's important. They both have log base 3. And then it's of two totally different expressions. Well, don't forget what the concept of an equation is. The concept is the left side in value is the same as the right side in value. They don't look the same, but they hold the same value. Well, they're both log base 3. If they're both log base 3, then the of part has to be equal as well. And so, draw y'all. That, wrong arrow, note, and match. So, 5x minus 1 has to equal x plus 7. Subtract, so that's 4x equals 8, x is 2. Right? I like logs because they're like puzzles. You have to actually think. Keep your mind sharp. We're going to hold off on 5 for right now. I may make 5 like an extra credit, but you can see why we're holding off on it, because it's going to end up being in quadratic form, and you've got to do that U substitution to reduce it, and you'll solve by the quadratic formula. Let's make it a challenge question, so it's optional. The answer is ln 3 plus or minus 2 root 2. That is the answer. If you can get there, that's awesome. If not, doesn't mean you're not checking the boxes. Don't worry about it if you can't. The goal is one day you can. That's the goal.
Guess what? I wrote the answer down. I got it.
Nice. It's quite a bit of work. Don't know how my handwriting is. I mean, I ended up writing all straight down, and then I came over here to plug what I plugged U in for. The U. It's U substitution.
It's U substitution?
It is U substitution.
Yeah, no, I'm not doing this. Have fun with that.
All right, let's go to the next slide. I would encourage you to try it. You never know. I'd love to see how far can you get, even if you feel like you're not going to be able to do it. Please don't shy away from challenge questions. Don't shy away. Go to this one. This is a log equation. It says to solve. Do you have a log on both sides? No. So this is not like the last one where we had a log on both sides. You have a single log. Let's convert it to exponential form, and let's see if it brings the x out, the exponent, and if we can work with it.
It does.
Convert
3 negative.
to exponential. Everybody do that. Convert to exponential. Make sure you're trying it. Make sure you're not waiting on me to put it on the board, because when you get to the test, you're going to freeze. You're going to be like a squirrel in the middle of the road trying to decide which way to go. And I'm behind the wheel screaming, just pick one. All right, the base of the log is 3. The other two switch.
Okay, so I'm going to one.
Now x is by itself. Go to the calculator, type it in. You can probably do that in your head though. It isn't, it should be in fraction mode. Should be able to. 3 squared is 9, but it's a negative 2, so it's going to be 1 over 9, right? I would love to say there's more to show here, but there's not. But there is on the next one.
Uh-oh.
That's easy. Let's go to the next one.
That was perfectly easy enough. I think that should be all of our tests.
This one? Oh, the challenge question? You'll work with the E all the way. LM. Yeah. All right, go to the next one. Or you can type this log basically, but then this is the end of LN. All right, look at this one. Nope, don't do that. Log x plus log of x plus 3 equals 1. Do you have a log on the right?
No.
No, you have just a 1. If we had a log on the right, then we can take all the of stuff and we could apply the rule from 5-4 and we can solve it. We don't have a log on the right. What do you notice about the 2 logs you do have? They do both have x, but I'm looking at something else. You notice that neither of them shows the base, which means they're both base 10.
So x equals x plus 3.
So we can write it as a single log. This is 5/4. You have two logs in expanded form with the same base. You can write it as a single log using your 5/4 rules. This is plus translates to multiplication. So these logs are going to come together as a single log. You can write the base 10 if you want to. If it bothers you, you can. You don't have to. And then the of part of x and of x plus 3. It's being added, so it's going to translate to being multiplied. And that's a lot right there to be attached to that log base 10. So I'm going to put giant brackets around it so that I remember that is all one thing. If you don't want to do brackets, just do really big parentheses. It's just to say to yourself, okay, that is all in the of part. I don't like this. It's x times x plus 3. Let's clean that up. What is that? Yeah. Now I only have one set of parentheses. It's in log form.
Exponential.
Let's go to exponential. There's only one log here, so switch to exponential. The base is what? 10. The other two, switch. The log's gone. The exponent, or the x squared plus 3x is on the right. Quadratic. You're going to have to think back on how to solve a quadratic. You have 5 choices in solving a quadratic. The majority of the time, don't mark me like saying, she said every time. No, I didn't. I said majority. The majority of the time they will factor. Okay? But like that challenge question that I just gave you, quadratic formula. So shoot for factoring first because most of them factor. And if it won't factor, look and see if you can do square roots. And if not, then go quadratic formula. Please don't try to complete the square. All right. 10 to the first power is just 10. If it bothers you, you could rewrite this. Just say, okay, so that's a 10. Or you could just go over there and erase the 1. It's up to you. But now you should recognize this is a quadratic. We've got to solve it. First step to solving quadratic, if it's not by square roots. Can I use square roots here? You remember how to recognize when you can and can't?
Yeah.
There's a square and if the bx term is gone, you can solve by square roots. The bx term is right here at 3x, so we can't do square roots. So I'm going to move 10 to the right by subtraction. And then now I want you to check and see if it will factor. Yeah, it should. Factors of negative 10, so there's a 1 here. Don't forget to multiply by the a. Factors of negative 10 that add up to equal 3, 5, and negative 2. Since a is 1, we can go straight to parentheses. Now you have the zero product property. This times this has to equal 0, which means one of them has to be 0. Just force both of them to 0 and solve. So what 0 comes out of this factor? Negative 5. And what 0 comes out of this one? Positive 2. Now we have a problem though, Houston. Because you've come to 2 answers, you've got to plug both in to find the one that is extraneous and the one that is the actual answer. So we're going to check x equals -5, and we're going to check x equals 2. How do you check it? You go back to the original, and you plug it in. We got log -5 plus log -5 plus 3, and it has to equal 1. What did you find when you checked -5?
It's an error.
You end up with an error. Tells you not real, which means x cannot be -5. That's considered your extraneous answer, meaning algebraically it's an answer, but when you plug it back in, it's not in the domain. And then what about when you check 2?
1.
You end up with 1 equals 1, which means it works, so x is 2. Two more slides of practice, and then I have some slides copied from the homework as a hey, heads up. I did take 2 questions off the homework, I think it was, that are not relevant. You're welcome. You're welcome. Any questions on this one? I'm going to change the slide. Okay. All right, so go to this one. We've got log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. It'd be really nice if it said equals log base 3 of 2, but it doesn't. Because if it did, then you could just pull the ofs, apply the 5-4 relationship, and then you would solve. We do have matching bases right here, though, right? So because these match, we can condense that. I didn't mean to draw arrows. We can condense those down to a single log base 3. And then now you've got to look at the the operation between them to see how does it condense. Think of 5-4. Subtraction becomes a fraction. Use the rhyme to help you. And the order you fill in the fraction is the order it's written. If this is first, it goes on top. And this is second, it goes on bottom. And that's a lot, so I'm going to put it in parentheses. Okay, now I have a single logarithm, ugly, but I have a single one, equals something, right? So, it's not helpful. I can't solve for x here. What do I do?
Exponential.
Go to exponential, see what happens. Okay? What would the exponential be?
3 squared equals 2x minus 1 over x.
There you go. Oh, son, Mom said, clean your fridge. I'm leaving Costco.
What was that?
I don't know if she'll get here when y'all are in here. She's bringing me some desserts.
So they were coming back.
You multiply by exponential.
So what I would do first is what with the 3 squared? Let's change that to 9. And then you have several ways to go from here. Please don't have like some paralysis analysis about you. Don't forget the stuff you've learned over the last 4 years.
You can just cross multiply, right?
There it is.
Okay.
It's a basic proportion. That's a basic proportion. You do have a fraction equals a fraction, although you do need to group these so you don't forget to distribute. So you can solve this by cross multiplying. So the x minus 4 And then you've got the 2x minus 1, which doesn't go anywhere. Now we distribute. Now we solve. Okay, any questions on that one? All right, let's go to the last one.
Wow. Natural logs.
I like the LNs better.
This is an easy one.
When,
So you say.
we check to see if it is.
All the LNs
Well,
cancel.
we at least check that. And it'll be like, solution can't be.
Left, yeah, first put your right hand on.
Just the first two.
Like if it becomes a quadratic when you're solving. Because now you've taken what was linear, not linear, x to the first power, and to solve it, you've transformed it to x squared, which opens the opportunity for more, but it's a domain restriction. So not when it, only when you jump to quadratic and end up with two answers. All right. We've got ln of 4x plus 6 minus ln of x plus 5 equals ln of x.
All the LNs cancel, right?
They do. Do you remember something from 5-4 though? Like, okay, red means wrong. Don't write this. It is not.
It's division.
Like, don't write that because that's wrong.
4x plus 6 over x plus 5 equals x.
Bam.
Yeah.
Now, if you don't see it immediately, let me show you this. So, first of all, I'm going to take my highlighter and say, we got an ln, we got an ln. Ooh, we got an ln, right? Every single term is ln. Recall that ln means log base e. So this is the same thing as if every single one of these said log base e. Log base e, log base e. We've already practiced this. When the log and the base match, you can just take the of stuff. But before you run with that, I would remember the 5-4 lesson and condense it down to a single expression so you don't forget the 5-4 translation. You know what I mean? That is a subtraction that becomes a fraction. And I would do that first before you recognize, hey, they all have the same ln. I can just get rid of the ln.
Exponential.
You don't have to. So because it's ln of this, has to equal ln of this, and because it's an equal sign, like it's an equation, they're balanced in value. So since they're both ln, then the ofs have to match. So we can say, okay, the ln's here, the ln's there. I'm going to draw an arrow to say like, so, ... 4x plus 6 over x plus 5 has to be equal to x. Because they were both ln expressions. And once again, this is how do I solve it? It's a proportion. So there's an over 1 right here. You do have multiple terms there, so group them in parentheses. And now we're going to cross multiply. Now, unlike the last one, we now have an x times an x, which yields a quadratic. It's an x squared. So this is another one of those where have to check our final answers. I have way too many x terms to solve by square roots, so I'm going to subtract everything to the right. 4x would subtract under 5x, leaving you with x. 6 is positive, it would subtract to the right. Check A, don't forget about the A in case it was ever something other than 1. Factors of -6 that add up to +1. -3 and +2.
The other way, yeah.
+3, -2.
Yes.
Oh, he said the answers. That's what it was. He's pulling the 0 out, the factor out. You went ahead and solved it. You're good. All right, A is 1, so we don't have to worry about having to reduce. We've got x plus 3, x minus 2. And this is where he was giving the zeros that would come out of this. The solutions would be what? -3 and 2. But you've got 2 answers. You have to check them both. So we're going to check x equals -3. We're going to check x equals 2. You don't have no idea how I did what?
What?
What'd you say?
Talking to myself.
You could check it in the one where you condensed it right here. If you know for a fact you condensed it correctly. If you're worried you did that wrong, then check it in the original given problem. It's up to you. So that would be ln 4 times -3 plus 6 minus ln 4 plus 5, no, not 4. -3 plus 5 equals ln -3. Everybody try to type ln of -3 in the calculator.
It doesn't.
You get an error. You can't take the ln of a negative number because you're saying that e to some power yields negative whatever, and it doesn't work that way. So this right here gives you an error, which means there's no way x can be -3. So then checking this one, y'all are like, I'm done.
Just look.
Taylor,
Yes, ma'am.
grab my badge. It's on the other side of my lunchbox, on the outside pocket. She's in a white Honda Pilot.
Just let me get a piece.
Depends on how many she shares with me.
All right.
Because I don't share food.
Is she right out the door?
Brody and Taylor are coming out there now. When you checked 2, what'd you get?
2.3.
You should have gotten that the left equaled the right. So the answer is 2. I pulled 2 questions to show you. And I think I actually got rid of this one. Where's my trash can? Number 3. It's hard to see mine, but it says 4 to the x squared times 2 to the 7x equals 16. It's like a challenge question again. What do you know about 4, 2, and 16?
They're all in the originals. by
2. They are divisible by 2. Can I rewrite them as powers of 2?
No.
Yeah. 4 can be rewritten as a power of 2 squared, right? And then you got x squared. And then 2 right here, leave alone. And then 16 is 2 to what power? 2 to the 4th. So that's now there 2x squared. So all the exponents, you have an equation for the exponents. You've got 2x squared and then 7x and 4. They've all got to be equal. Now we've got multiplication here, so that becomes addition. That's a quadratic, yeah. Factors of 8 that add to -7, or add to +7. Oh, golly, that's all there is?
And there's all this. Just a little. Just get happens.
It's glass. Apple crumble.
I don't know.
Wheat and milk. I'm
We're
definitely
gonna
gonna have to eat one of those.
Somehow.
Don't drop that. What's that?
That's the.
Chocolate mousse.
That's how to get that. We gotta get all this in the fridge.
It's not gonna fit in mine.
Where are we gonna put it at? I can take it with me.
No,